Hey folks, today's topic is finding zeros graphically. If you remember last time we found zeros algebraically. So I kind of just did a description of what a zero looks like graphically. It's the x-intercepts. It's where it's the x values for which the function has a height of 0. So we're going to do that graphically. What we did last time algebraically, we basically just ZPP'd stuff and figured out where the zeros were. So now we're going to do it graphically. So let's start off. You'll need a calculator. Let's start off with this function. Let's see what kind of a window I get with, that's not a great window. I don't think I've got enough detail, so I'm going to make my window smaller. I'm going to use this feature called Zoom Box. If you hit Zoom, you can go to, right off the bat is Zoom Box. So Zoom Box, what you want to do is you want to take the cursor and you want to get to the upper left corner of a box that you could make that would cover up the region that you want. So I'm going to go over here, give myself plenty of room, hit enter, and watch what happens. You see how I'm making now a little box around my graph? And I can highlight this section that I want my calculator to zoom into. Now once I hit that, I get a much nicer picture. It gives me a better idea of what's going on here. Oops. All right, so here's my function. I want to figure out where the graph hits the x-axis. That's my goal. So you can tell that our graph hits the x-axis in two places. So the easiest way to find out where those locations are is using trace. Now the problem with trace, so I'm going to hit trace, is it can feel like you're at the spot, but you're not really. So it feels like, hey, that's the number that I'm at. You aren't necessarily, maybe that is, but it's not exactly that place. For us to guarantee that this is a 0, I'm going to not just move the cursor left and right. I'm going to type in the x value that I think it is. So I'm going to type in -1. How do I know that that's a 0? Pretty obvious, right? I got x equals 0. Or sorry, I got y equals 0. I got y equals 0. So one of my zeros, so the zeros of this function are x equals -1. Where does it look like our other 0? It looks to me like it's at 1, so I'm just going to hit trace again, type in 1, and it's going to, yep, how do I know that's a 0? Because the y value is 0. But we have a problem. If you remember from last time, the fundamental theorem of algebra says that you must have as many zeros as you have your degree. The degree of your function must be the same as the number of zeros that you found. So we only found 2 zeros. So this is where that multiplicity stuff comes back in. Now, it was easy to figure it out algebraically because if it was like x squared equals 0, that had a multiplicity of 2 because there was 2 zeros here. Graphically, it looks like there's 3 scenarios that we're going to have. There's mult 1, mult 2, mult 3. It's not that you can't have other mults, but we're only going to do mult 1, mult 2, and mult 3 in this class. So let's make a sketch of each one of the multiplicities. Mult 1, mult 2, and mult 3. Like I said, you could go further, but we're only going to go through these. A mult 1 looks like as it hits the graph. In other words, if I just zoomed in, let's say I zoomed into just this little part of the graph, and I covered up everything else except for, I gotta find something that doesn't have writing on it. What does that basically look like? If I just covered up this much of the graph, that basically looks like a line. That's how I know that that's mult 1. Because if I have an equation like 2x plus 3, that's a linear graph. That's a line. So a mult 1 is when your graph just busts through. And it busts through straight. So in other words, in that little section or at that 0, your graph looks basically like a line. I know it doesn't look exact. It's a little bit curvy, but hopefully you get the idea. Now, let's say we move on to mult 2. What happens if you take an x and you square it? What does that graph look like? It looks like a parabola. If I trace over here to -1 and I cover up again, everything else except that little section, what does the graph look like there? It looks like a parabola. And that's what a mult2 looks like on a graph. It will come up and it'll hit that 0 and then it'll bounce back off. A mult2 comes up and hits the x-axis and bounces. Now maybe it comes from this direction and bounces off the top. But it does hit the x-axis, but it doesn't bust through the x-axis. And then a mult3 is going to bust through, but it's going to bust through like a cubic. Remember our cubic from our parent function days? It's going to bust through, but it's going to bust through kind of curvy. So going back to our zeros over here, this 0 bounces off, so that means that it must be a mult2. Because this has a degree of 3, and we have 3 zeros accounted for, you don't have to write mult1. We have 3 zeros accounted for, so those are all the zeros. All right, let's have you try the next one. Pause it, try it on your own. Okay, let's see how you did. 2x to the third minus 2x. Hopefully my window's good enough. Yep, it's good enough because I can see all the places that it hits the x-axis. So I would take a guess. I'm going to guess that there's 1 at -1. I'm correct because the y value is 0. I'm going to guess there's 1 at 0. I'm correct because the y value is 0. And then I'm going to guess there's 1 at 1. I'm correct because the y value is 0. So my zeros are... So save yourself a little bit of time. Whenever you have zeros that are the same number but opposite signs, you can combine them into a plus or minus. So our zeros were at plus or minus 1 or 0. How many zeros are we supposed to find according to the fundamental theorem of algebra? We're supposed to find 3. 1, 2, 3. We found 3. We're good to go. They all are mult1s. Okay, let's look at the next one. X to the 4th. Subtract 2x squared. Windows good enough? Yep. All right, so the point of this example is what happens when you can't guess. Because look, if I trace to -1, nope, that's too low. It's not at a height of 0. If I trace to -2, it's up here at 8, which isn't even on the graph. So this is at some other place. Well, let's say it's -1.5. Nope. This has to be 0. For your answer to be, for your x value to be considered a 0, the y value must be 0 as well. Let's say 1.4. Pretty close, but not exactly 0. So I'm not going to sit here and play guess and check until I get the right answer because my calculator will do that work for me. Above trace is this word calc. Everything good on your grapher will be found underneath calc. So second, calc. And you see the second thing down is 0. I want to find a 0, so I'm going to select that. This is similar to what we did with mins and maxes. We got to get to the left of the 0, we got to get to the right of the 0, and then we have to take a guess. Right now, I'd say I'm basically on the 0, so I'm going to move a little bit to the left, hit enter. I'm going to move to the right, hit enter. Then I'm going to get as close as I can and hit enter again. So it spit back -1.41. What color? So now my zeros. One of my zeros is at -1.41. Is that a mult1, a mult2, or a mult3? It busts through. It's a little curvy, but it's basically straight. So that's a mult1. Now look at my next 0. I'm going to take a guess that this is at 0. And I'm right. Because my y value is 0. So you don't have to always use trace, and you sometimes can't use guess. But you should always try to guess first to save yourself some time. So then I found another 0 at 0. And then let's find this other one. Second calc, 0. I want to get somewhere to the left of it. Technically, I could hit enter right now, but I like to get a little closer. Enter. Get on the other side, enter, then get close enough, enter. Oh, shoot, I should have done a plus or minus. Maybe I still can. Plus or minus. Yeah, there we go. So how many zeros do we have? 1, 2, 3. Crap, we're supposed to have 4. So where's the other 0? Well, we should have said it when I drew it. I didn't catch it. This came up, bounced, and went back down. So this is a malt 2. So I have my plus or minus, positive 1.4, negative 1.4, and then 2 more zeros there. I'm going to encourage you to pause and try to do the next couple ones on your own. So is this a good window or a bad window? I'm supposed to have 3 zeros. That's a malt 2. That's a malt 1. So yeah, it's good enough. I don't care how high it goes, right? We're trying to find zeros, so we're trying to figure out where it hits the x-axis. Now, I can't just guess and check. Maybe I could. I don't know how nice this comes out, but I'm not going to waste my time trying to guess and check. I want to find the 0. I'm going to move my cursor. Now, sometimes you lose the cursor, but just follow these numbers down here. So negative 0.7, negative 0.8, there it goes. Now I can see it. Get somewhere to the left, enter. Get somewhere to the right, enter. Take a guess. Negative 1.7. All right, does that bounce, bust through? Obviously, it bounces. So this has a 0. Zeros occur at x equals negative 1.7. And because it bounces, that's a malt 2. Now I got to go find the other one. Second calc, 0. Be careful, don't hit it too fast, especially those of you who have the fancy new ones. Might just zip right by. You don't even know you went past it. Oop, there we go. Left, enter. Right, enter. Take a guess. 0.8. Now, does that bust through or bounce? Bust through, and it busts through basically straight. So x equals 0.8, which makes sense because we already had a malt 2. That's 3 for our total of 3 zeros. If you haven't yet, pause and do the last one. Okay, let's see how you did. Good window, bad window. Bad window. Because I can only see, I know there has to be 4, and that's definitely not a malt 4. So I'm just going to do a zoom 6. Zoom 6 takes you to the standard window, and then you can try to adjust it from there. Yeah, let's close it down a little bit. So let's play the game where we don't use the box, but we just use the window settings. So the farthest my graph goes to the left is -3. The farthest, I always like to give myself an extra room, a little bit extra room. So that's -3, 1, 2, 3, and then +4. So I'm going to go -3 and +4 for my x's. And let's see if that's a good enough window. Yeah, I'd say that's good enough for me. Now I'm going to guess because I think these are going to turn out nice. I'm going to trace to -2. Yes. So one of my zeros is at x equals -2. Does this bust through or bounce? The line busts through the x-axis. So that's a malt 1 or a malt 3. But because it busts through straight, it's a malt 1, which means I don't need to write it. I think the other one is at 3. Yep, because the y value is 0, so I know that's right. Does this bust through or bounce? It busts through, but how does it bust through? Curvy. It looks like a cubic, so that's what a malt 3 looks like. So take a second there, just think a little bit about what's a malt 1 versus a malt 3, because those can get a little bit tricky. And we might not have known this was a malt 3 if we didn't adjust our window. So you got to play around a little bit with your calc. So now we are, instead of being given the function, we are going to create the function based on the zeros. I always believe that you really know mathematics if you can go the other direction when you're doing something mathematical. So we've started with the equation and found the zeros. Now we have the zeros and we're going to work back to come up with the equation. There's one thing that I really want to highlight here. Do not expand. 2 exclamation points. So your answer should have a bunch of parentheses in it. I don't want you to have to distribute because I don't want to distribute, and I don't want to have to figure out if your distribution was right. All I care about is if you can figure out what the equation could be without expansion. All right, so what should my function look like here? So there's a couple of things that we're going to identify. The degree is not that helpful, actually, because the degree, look at 1, 2, 2. Degree, multiplicity of 2, 1, 2, 3. So I feel like I have to write the degree, but it actually doesn't help us a whole heck of a lot. Leading coefficient and zeros are the two things that are going to really matter. Leading coefficient is going to be one that's going to drive you crazy if you get it wrong because it's so simple. If you have a leading coefficient that's negative, you have to have a negative out front. Now, if you want to make it a -2 or a negative, I don't care. But I'm just going to put a negative there to create the negative coefficient. Now, I need to create pieces that when I ZPP them, I get a 0 at x equals 2. So it's kind of like I'm doing a reverse ZPP. I want to make this thing equal to 0, which means I got to take this 2 and bump it to the other side. That creates then what we call a factor of x minus 2. If I took this 4 and I bumped it to the other side, that would create a factor of x plus 4. Now, if I gave you this problem last time when we did finding zeros algebraically, you would ZPP this and you would find those two zeros. So that's how you can do a quick check. Just look and see, once you ZPP it, do you get the zeros that you had before? Okay, so next up, we've got degree 3. We've got x equals -2 with a mult of 2. We're going to talk about what that looks like. And then we've got this one weird fraction thing. So you're not allowed to have fractions. So let me make that little note right now. No fractions. So what we need to do is we need to do a little bit of algebra when we reverse ZPP. Now it's easy when we've got just a regular number. So f of x equals, my leading coefficient is positive. Don't fall for that. So I don't have to put anything out front. I can if I want to, but I don't have to as long as it's positive. When I bump this to the other side, I get x plus 2. Now because this is a mult 2, I've got to make it happen twice. So that's going to give it a squared. Then to make sure when I reverse ZPP this, I've got to make sure that it's not a fraction. So the first thing I'm going to do is I'm going to times everything by 3. So 3 times x is 3x equals -1/3 times 3 is -1. Now I can bump this 1 over and I get 3x plus 1 equals 0. And we've eliminated the fraction, but we've still kept -1/3 as a 0. Let's have you pause here and try to do the next two. So, because x equals 0 is already equal to 0, I don't have to do anything fancy to that. I can just say x. Now, if it helps you understand it, put it in parentheses and do x plus 0 or x minus 0. That's fine. It's mathematically embarrassing, but it's fine. But x, and it happens twice, so that's going to become an x squared. Now I'm going to reverse ZPP this, which means I'm going to times the 2 over. Then I need to subtract the 3, so that leaves me with 2x subtract 3. Then I'm going to bump the 1 over, and that leaves me with x plus 1. Okay, hopefully you got it. Try the last one. Be careful. F of x equals, leading coefficient is negative. Reverse ZPP, the 5 is going to go over, and then I'm going to subtract 2. and that's happening twice. The 7's going to go over, then I'm going to add 4, and that's happening thrice. Okay, last little bit here. Make a reasonable sketch of a polynomial given its factored form. So we're kind of taking the ideas that we've done up here, and we're now putting them all together here. So I'm going to take my factored equation, I'm going to find the zeros, and then I'm going to use the degree and the leading coefficient to help me determine which way my parabola or my polynomial has to go. Well, let's find our zeros first. So what's nice about these, they're already factored. So we can just go right into writing them out. So my zeros, if I ZPP this, I get x equals 0. ZPP that, I get x equals -4. ZPP that, I get x equals 2. So that means I have a 0 at 0, 1, 2, 3, -4, and 1, 2, +2. These are all mult 1s. So when I'm gonna draw my curve, I'm gonna bust through each one of these. But what I don't know is, does it go down like this, up and then down again, or does it go up and then down? So what I need to do is I need to determine the end behavior of my graph, and that comes from looking at the degree and the leading coefficient. Our degree here, if I distributed all this, I would have 3 total x's. My leading coefficient, a negative times a positive, is going to end up being negative. So what is an odd function with the leading coefficient that's negative? This goes back to our end behavior stuff. So positives, want to go positive. A positive 3 times is positive, times a negative, though, is negative. This side needs to go downward. These are negatives. 3 times would be negative, but we're timesing it by another negative, so this side needs to go upward. So what I do is I draw these little arrowheads to give me an indication of which way my graph needs to go. Then I go back to my actual answer color, and then now I'm going to draw. So this side's going to be up. We said this was a mult 1, so it's going to bust through. I need to curl and hit this next 0, and it's a mult 1. It's going to bust through. Curl and hit this last 0. It's a mult 1, and it's going to bust through. So there's my reasonable sketch of the polynomial f of x equals blah, blah, blah. If you feel like you're ready, pause it and try to do the next one. If not, we'll do this one together. So I'm going to identify my zeros first. X equals 3 with a mult of 2. And x equals -2 with a mult of 2. So I've got 2 zeros, and they're each mult 2s. 1, 2, 3. 1, 2, -2. Now I need to figure out which way my graph goes. And the way I figure that out is I look at the end behavior and the degree. My degree, if I expand all this, there's going to be 2 x's here and 2 x's there, so my degree would be 4. My leading coefficient, that's a positive, and no matter how many times I multiply positives, I'm going to still get a positive. So the positive side gets to the 4th power times another positive would still be positive. Negatives to the 4th power would be positive times another positive, so this side would also be positive. Okay, so now I'm going to take these end behavior arrows, and I'm going to combine them with the mult 2 zeros. So my graph's going to come in, it's going to hit, and it's going to bounce off because it's a mult 2. Now, as my graph goes up, eventually it needs to curl back down, but it's going to hit and bounce again. There's my graph. Now, you could have maybe drawn yours, this little loop goes higher, maybe it goes lower. I don't really care. What I care is that your graph bounced. Now, I got a little bit sloppy there. I went down a little bit too low, but that should really just only hit that point. This one I did a really nice job of indicating that it bounced only at that point. You don't want to go through and then come back up on the other side because it creates another 0. All right, this last one's all yours. Pause it, give it a try. Is this a 0? No, that doesn't have an x. When I ZPP it, I would get -2 equals 0, which makes no sense. So we don't have to worry about that. So that's just a leading coefficient. So my zeros are going to be x equals negative 3/2 and x equals 3 with a mult of 3. So negative 3/2 is negative 1.5. 3 is 3. Now I need to look at the end behavior. So my degree would be 3 of them and then 4. My leading coefficient would be a negative. So that means the positives would want to go positive, but there's a negative. The negatives want to go positive, but there's a negative. So both the ends are pointed downward. Okay, so this needs to be a mult. When I hit this, this needs to be a mult 1. Sometimes it's nice to label these so that you remember what they actually have to look like. So maybe this is something you want to do. It doesn't really matter to me. Mult 2, mult 2. Okay, a mult 3 is actually, people really struggle with drawing a mult 3. So here's my mult 1. I'm going to bust through, no problem. Now what I recommend when you draw a mult 3 is go to the mult 3 and draw half of a parabola and half of a parabola. Now that half is easy. And why did I draw this half up? So that it would connect. I knew it had to connect with that side. As long as you get decent, it can't be terrible. It can't go straight through. It's got to look curvy like this. Talk to me if you need help sketching what a mult 3 looks like. All right, folks, go get them.